Now let us try to figure out how to measure the efficiency or time complexity using BigO notation. In order to do that, we will assume that we have n number of data items with us and our algorithm is doing some operation on them. In order to calculate the efficiency, the first step is you have to figure out the most dominant operation in your piece of code or pseudocode or algorithm or program. The most dominant instruction means the instruction that executes the maximum number of times in your program. To find the most dominant instruction, I can share a quick tip with you all. If your program is a simple sequential program without any loop, then you really do not need to worry about the most dominant instruction. It is very straightforward. You can just count how many times an instruction is executing, just like that. And but if your program has loops inside it, then you have to identify the instruction which is executing in every iteration of the loop. So basically what you have to do, you have to identify all the loops in your program, and also you have to identify the instruction inside those loops that is executing all the time in every iteration. After that, now it's the time to calculate how many times actually that dominant instruction will execute in that entire piece of code or pseudocode. Let's notify it with t, that is t times the dominant instruction is executing. After that, after you got the count that how many times it is executing, now in the step 3 you have to create an equation, or simply you can say create a function by expressing that t in terms of n, where t is the number of times the dominant instruction is executing and n is the number of data items. So basically you have to express this t as a function of n. After that, what you have to do, you have to get rid of all the constant terms. What does that mean? Let's say you got an equation in step 3 as t equals 10n square plus 23n plus 12. So what you have to do, you have to get rid of all the constants like 10, 23 and 12. That is, get rid of 10, get rid of 23 and also get rid of 12. So here actually just get rid of 10. Just keep this n square. So now your new equation is just t equals n square plus n in here. So after that, now we are at the last step. In step 5, what you have to do is you just keep the only fastest growing term of n. What is the fastest growing term? Fastest growing term means the term of n which has the maximum raised to the power. For example, in this equation, like t equals n square plus n, this n square is raised to the power 2. So that is why you have to keep only n square, because the other term is raised to the power n means n raised to the power 1, and you can just get rid of this term also and just keep this n square. So after keeping only the fastest growing term, that is the term with the maximum power of n, Now you are ready to write down, ready to tell the big O time complexity. This is basically, it is now the algorithm has, you can tell that you're, after doing all these things, you can easily, you can tell that okay, your algorithm or pseudocode or your program has an efficiency of order of n square. You can either call it order of n square, or you can call it big O of n square. So well, one more thing, O stands for order of. Order of n square means the, if one data item is added, the time is actually increasing as a square of it. So in this equation, in this logic, the big O is the efficiency of this program is, or big O of n square.